Hi class, in 16.2 our learning target is going to be which measure of center that we should end up using. We want to try to determine when to use the mean, median, or the mode. So if you take a look at page 1082, we'll get started with problem 1 and compare the means and medians of two data sets. At the top of page 1082 it says, previously you determined the balance points and calculated the means of various data sets. What they want you to do in number 1 is graph the numbers 2, 3, 5, and 6 on the first line plot, and then 2, 3, 5, and 10 on the second line plot. When you're done doing that, they want you to place a black triangle underneath the number line plot at the location that represents the balance point. So go ahead and do that with your group members. Here are what your two line plots should look like then for number 1. Go ahead and answer number 2, number 3, and number 4 then with your group members based off of those two line plots that you constructed in number 1. If you take a look at the answers for number 2, 3, and 4, for number 2, the mean increases when the data value of 6 is replaced with a data value of 10. For number 3, the median for each data set is 4. And for number 4, the median stays the same when the data value of 6 is replaced with a data value of 10. Take a look at number 5 then at the bottom of page 1082. Go ahead and use the number lines shown to complete the dot plots. So here are what your dot plots should look like for number 5. What I would like you to do then is turn to page 1083 and answer letter B, letter C, and letter D based off of the two dot plots in number 5. Let's take a look first at letter B. For set 1, the mean is going to be 55. You can determine that by finding the balance point. You can also use the arithmetic method that we did back in 16.1, adding all 5 of the numbers up and dividing by 5. The median is 55. You can determine that by seeing that there are 5 points on the dot plot. 55 is in the middle. 2 of the points were below 55, while 2 of them were above 55. Remember, if it's an odd set of data, you're going to have exactly one median. Finally, there were 2 modes for set 1, 50 and 60. You can determine that by seeing that there were 2 x's for both 50 and 60 on the dot plot. For set 2, you obviously can find the mean, median, and mode the same way that you did for set 1. I won't repeat that. The mean for set 2 was 50. The median was 55. And in the second set, there was only one mode, 60, because you saw 2 x's above the number 60 in the dot plot. In finishing up with letters C and D then, hopefully you noticed that the medians are the same for each data set for letter C, and for letter D, the means are indeed different. Set 2 is less than set 1 on both of those dot plots. What I want you to do then at the bottom of page 1083 is finish up with letter E. Very important question here, so make sure you discuss it carefully with your group members. Why do you think the medians of the data sets are the same, but the means of the data sets are different? So talk about that with your group for letter E. And looking at the answer to letter E, the medians are the same because the median describes the middle number in a data set. It is not affected by the values of the least and greatest numbers in the data set. The means, on the other hand, are different because the mean is the balance point in a data set. If there are going to be extreme values that are not close to the other values in the data set, then the mean is going to move toward the extreme values in order to try to balance out the data. We're going to go ahead and skip number 6 and number 7 at the top of page 1084. We will come back to both of those problems. So let's go ahead and move to problem 2 at the bottom of page 1084. If you take a look at problem 2, It says for number 1, previously you examined a data set about the number of minutes students at Sharp Middle School exercise. The data are shown here. What I would like you to do to get started is take a look at letter A, construct a dot plot of the data. Here's what your dot plot should look like for letter A. Hopefully you notice that the intervals are increasing by 20s. What I would like you to do then is take a look at the top of page 1085 and answer letter B with your group members. So hopefully you're thinking back to what we talked about in problem number 1. Karen says the mean will be greater than the median in this data set. Do you agree with Karen's statement and explain your reasoning? So based off of the dot plot that you constructed in letter A, let's talk about what you discussed with your group members. So here is what you should have come up with for letter B. Hopefully you did agree with Karen's statement because the greatest number in the data set is 300 minutes, which is far away from the other values in the data set. Therefore, the mean is affected by this data point. Remember, it wants to try to draw itself. If that extreme value, which is 300 minutes, is far away from the other values in the data, then it's going to pull itself toward that number in order to balance everything out. So it will definitely be greater than the median. The median will be closer to where most of the data values are because it is not affected by that 300 data value. We're going to skip over to page 1086. So if you can turn to page 1086 and take a look at number 2 with your group members. So if we take a look at number 2 at the top of page 1086, it says the stem and leaf plot shown displays the scores of the students on a 100-point math test. So what I would like you to do with your group members is answer A, B, and C. We're actually going to skip letter D. We will come back to letter D, much like we're going to come back to number 6 and 7 from problem number 1. So go ahead and do that with your group members. If you take a look at letter A, it asks how many students are represented in the stem and leaf plot and explain your reasoning. There are 25 students that are represented in the stem and leaf plot, and you know that because there are 25 leaves in that part of the plot. For letter B, it asks you what is the mode of the scores. The mode of the scores is going to be 87. If you examine each row of the stem and leaf plot, the row with 8 as the stem contains 3 sevens. If you take a look at this part of the stem and leaf plot right here. Since this is the most number of times a leaf occurs in one row, then 87 would be the mode. Finally, for letter C, what is the distribution of the data? That would be skewed left. You can see that the peak of the data is to the right and the data tails off or slants to the left. Moving to the top of page 1087, go ahead and answer letter E and letter F with your group members, again based off of that stem and leaf plot from page 1086. If you take a look at the answer for letter E, how to calculate the median test score, and then finally determine what it is. What you just want to do is start at the beginning and the end of the stem and leaf plot and mark off the leaves while you are moving toward the middle or the center of that stem and leaf plot. If you do that, you will see that the median is indeed 85. For letter F, it says determine the mean of the set of data. Again, if you add all of them up and divide by the total number of values in the data set, you would get 80.56 for your mean. Remember, in answering both letter E and letter F, if you refer back to letter A, it says that there were 25 students, so you know that you are adding all those numbers up and dividing by 25 to get your mean. And as far as the median for letter E, that's an odd number as far as the set of data goes, so you know you're going to have exactly one median for letter E. Let's continue on page 1087 then and take a look at number 3. It says the histogram shown displays the number of hours students spend playing video games. So what I would like you to do with your group members based off of that histogram is answer letter A and letter B. We're going to skip letter C, much like we did with letter D on the previous page, and number 6 and number 7 from problem number 1. I will come back and answer those at a later time. So go ahead and answer letter A and letter B for number 3 on page 1087. If you take a look at the answer for letter A, how many students are represented in the histogram? There are 25 students that are represented. If you take a look at each of the bars, the first bar represents 3, second bar 5, third bar 7, and the last bar 10. So if you add all those together, you get 25. For letter B, the distribution of the data for the histogram would be skewed left. The data peaks at the right and tails and slants off to the left. Let's go ahead and finish up problem 2 at the top of page 1088. Go ahead and answer letter D and letter E with your group members. In looking at the answer to letter D, it says, can you determine the mean, median, and mode of the data set by examining the histogram? Why or why not? No, you cannot determine any of the measures of center because you do not know the data values. Remember, histograms deal only with intervals and ranges of numbers, not individual data. For letter E, it says, would the mean or median represent the center of the data, and why? The median would better represent the center of the data since it is closer to the middle of most of the data, and again, it is not affected by the lower values. Let's finish up 16.2 with problem number 3 then. We want to ask the question mean or median, which is greater and when. So it says underneath problem 3, previously you learned about 3 common distributions of data: skewed left, skewed right, and symmetric. Now the next part of these directions, if you take a look at the next part of the directions, it says, you have also learned that the distribution of data can determine when the mean or median is greater or less than the other. Now, those are some of the problems that we have previously skipped over and we will refer back to. I want to do that after we look at these diagrams that they have laid out for you. So let's take a look at these 3 diagrams underneath for skewed right, symmetric, and skewed left. Okay, if we take a look at the distribution skewed right, it talks about focusing here now, talks about the mean of the data set is greater than the median when the data is skewed to the right. And if you look underneath that, it says that the median would be the best measure of center because the median is not affected by very large data values. Hopefully you understand that by now. As far as symmetric goes, it says the mean and the median are equal when the data is symmetric. So you can see them right on top of each other in the diagram. And in this case, the mean would be the best measure of center to use. Finally, for skewed left, it says the mean of a data set is less than the median when the data is skewed to the left. And in this case, the median is the best measure of center because the median is not affected by very small data values. So make sure that you refer back to these diagrams and these bullet points as far as understanding how to use the distribution of data when trying to figure out if the mean or the median is greater or less than the other. With an understanding of everything here at the beginning of problem 3 now, let's go back to page 1084 and look at numbers 6 and 7. So remember, you're referring now back to the dot plots on page 1082 for number 5. Go ahead and answer number 6 and number 7 with your group members. If you take a look at number 6, hopefully you saw that in set 1 the distribution would be symmetric, and in set 2 the distribution would be skewed left. For number 7, it asks, how do the values of the mean and median appear to be affected by the distributions of the two dot plots? If you take a look at set 1, the mean and the median are going to be the same because the distribution is symmetric. Both the mean and the median are in the middle of the graph of that dot plot. For set 2, for number 7 then, the dot plot is skewed left. The median is closer to where most of the data is, and the mean is less than the median and less than most of the data values then in this case. So like I said, hopefully it's a little easier to understand how the distribution affects the mean and the median after you saw those pictures at the beginning of problem 3. So now again, let's skip over to letter D on page 1086. This is another one of the questions that we skipped. It asks, do you think the mean test score is greater than, less than, or about the same as the median score from the stem and leaf plot at the top of the page? So go ahead and talk about that with your group members. So this question for letter D is asked right after letter C. Your answer for letter C, if you remember back, was skewed left. That's going to mean then that for letter D, that the mean will be less than the median. In order to balance the data, the mean will need to move toward the lesser values. Let's go back to the last problem that we skipped as we went through the lesson, letter C at the bottom of page 1087, referring to the histogram. It says, do you think the mean number of hours spent playing video games is greater than, less than, or about the same as the median number of hours spent playing video games? And then explain your reasoning. So again, take a look at letter B as far as what the distribution was and answer the question with your group members. Very similar answer to what we just saw in the last example. You said that the distribution was skewed left back in letter B. The mean would be less than the median because the graph is skewed left. That means that the median is closer to the middle of most of the data, but the mean is going to be less than the median because of the lesser values on the left side of the histogram. Remember, it wants to pull itself toward those lesser values, so that's why it's going to be less than the median. Now let's pop back over to problem 3 and finish up on page 1088 and 1089 with the rest of problem 3. At the top of page 1089, let's take a look at number 1. It says, for each plot shown, first describe the distribution of the data, then determine whether the mean is less than, greater than, or about equal to the median. And remember, you can refer back to the pictures that you saw on the previous page to help you come up with these answers. So go ahead and answer letter A, letter B, and letter C. If you take a look at letter A, the distribution for the stem and leaf plot would be symmetric, and that would mean that the mean is about equal to the median. For letter B, if you take a look at that dot plot, you can see the distribution of the data is skewed to the right. That would mean that the mean is greater than the median. Remember, it's going to want to draw itself toward that greater value or that extreme value to the right part or to the right side of that dot plot. Letter C, much like letter B, the distribution of the histogram is also skewed right, so that would mean that the mean is greater than the median for letter C. To finish up for today then, take a look at the top of page 1090 and go ahead and answer number 2 with your group members. For each question, for each part in question 1, should the mean or the median be used to describe the center of data? Remember, that was our learning target from the start. So take a look at number 2 and answer that with your group members. If you take a look back at letter A, you're going to want to use the mean because the distribution of the data is symmetric. So that's going to be the best measure of center to use. And for letter B and for letter C, you're going to want to use the median. In both of those cases, the distribution is skewed right. But again, it doesn't matter which direction it's skewed. If it's skewed right or if it's skewed left, you're always going to want to use the median because that is going to be closer to the rest of the data, the values in the data that you see. The mean is going to lend itself to either go left or right toward that extreme value, and therefore not be the correct measure of center to use. That's it for 16.2. Please let me know if you have any questions. Thanks.